Welcome everybody to this should be day 3, I guess,
Yes.
of the PL 300 prep class. Some basic things want to give some foundation, which is very important. Not just going through the past questions and answering the questions, but we also want to look at some of the topics that are related to those questions, which is very important. And last week when we met, this is a typical warehouse architecture of a sales environment, sales, logistics, procurement environments. And we were able to see, oh, I think I love that comment I was showing. What did you,
Oh, okay. I didn't
please let
want you
it
to
show.
block
I
the.
think I like it somehow.
Okay.
Thank you. So we were able to discuss things around fact dimension tables. We saw the interrelationship between some dimensions to some other dimensions. Some of the examples I think was that when we were talking about sales table, I think we talked about something like a truck ID, and we said that for every truck ID, for every truck, there's a driver attached to each truck, right? And that when we need the driver information, we don't need to bring in driver ID to the sales table again because we already have what the driver information attached to the truck table. So there is that linkage between these different dimensions, right? And what I was to tell you guys last week that I didn't talk about because of our time was that you see this structure that you see here, they usually use this in what is called an OLTP. You can write it somewhere on the screen, online transactional processing. I think Madam Dola has said it before. You are not new to that term, right?
Yeah.
Okay. An OLTP, online transactional. Now, Paul, and I don't know who is this Adebayo that is here with us. Okay. So, Paul, uh, let me explain this OLTP for you so that you understand what it means. Madam Lolatu can, contribute based on uh it's not first time she understands it. So OLTP is this. So when they build an application, it's Paul here with me. When they build an
Yes,
application,
Samia.
for example, we build an e-commerce application. Let's take DoorDash for an example as an example. Or let's take Uber app as an example. When they are building the application itself in itself is not a database. It cannot hold data, right? But they usually integrate the application with a database. So as you're taking orders, for example, you are ordering a ride, somebody is in Saskatchewan that is ordering ride, there's somebody in Vancouver, in Toronto, they are ordering ride. Everybody is ordering ride at the same time, right? All the information of you, let me start from here. From the point of your sign up, when you sign up on the application, you download the app, you sign up as you sign up as a customer. Your information goes to a particular table. That table is raw. It means that the information that you put there is raw as it is from the way you put it there. So no cleaning has been done. It's just raw information that is going inside that database. Now, let's take another e-commerce. Let's take like an e-commerce application. From the point of sign up to the point of you transacting on the application, all the transactions, the information, the details about the transaction, the order, the location it happens, the name of the customer, what the customer bought, at what quantity, all those information, they go into this OLTP. Is the one that is integrated with the application that has been built. It has no, the data there is not clean. Now, but this is the kind of structure that you see here. We call it normalized schema or normalized structure. Let me explain what that means. What the normalized means is that instead of us putting all the information on one big single table, right? Because that database, that raw database that raw information goes into, because it is optimized for fast write. We call it fast writes, right? It's optimized for fast writes and fast read. Let's start with what fast write means. Fast write is that we are writing into that database. Writing means that information is going inside of it, right? At the same interval. So it means that if you want to order Uber and I want to order Uber, different people in the world can order Uber at the same time. We don't have to wait for ourselves. We don't have to queue, right? So at the same time, the same second, the same minute, the same hour, the same whatever, the information of that order can go into that database at the same time. Do you understand what is this about now, Paul? So because we are writing into it at different points in time, almost every second, right? So the structure is optimized. The structure is like this because of what this database is optimized for. It's optimized for fast writes. And for that fast write to work, we have to break down the different entity into smaller components, smaller components, right? That's why you see that, for example, when we talk about the warehouse entity, everything that relates to warehouse, for example, the warehouse itself, the driver, the truck, the warehouse manager, everything that relates to the warehouse, will break it down. Warehouse table is standing on its own, driver table is standing on its own. We will have put driver and truck together inside one table, but no, there is that breakdown. That breakdown is called normalization. So this is the structure of how an OLTP looks like. Because of what it is optimized for, that's why the structure is like this. Now, we have what is called OLAP. And Ola, you can write it there. OLAP is online analytical processing. That's now our data warehouse. Can you hear me, everybody? Is Paul
Yes.
here with me?
Yes.
Okay.
Yes, I'm here.
We have online analytical. That is our data. That is now when we've now transformed that raw data in its way it is in the raw state. We've cleaned it. We've denormalized some tables together. It has gone through some transformation, some business logic, and all of those things. We now load it. That's where you now hear the word the word ETL, extract, transform, and load. Right? We now load it into a warehouse. That warehouse is called OLAP, online analytical processing. Now, the data inside of OLTP cannot be used for analysis. Are you getting my point now? It cannot be used for what? It's the raw data in its raw states. It cannot be used for analysis. But you see that one in OLAP, the data warehouse one, is the one that we usually use. It's the one that the Power BI developer, the data analyst, analytics engineer, they connect to build dashboard, to build reports. Is that clear, Paul? Is that clear, everybody? So that
Yeah.
it's good to know this distinction between these two is a core foundation of data. Whether you are a data engineer or analyst or whatever, this is the core foundation that everybody should know. So the analytics, even from the meaning online analytical process, it means that this is the one that is optimized for analytics. This is the one that we can connect to for our reporting to answer business questions. Now, the structure inside this one is usually a star schema or snowflake. Now, the structure will not be like the one you are seeing on Madam Lola's screen. No, it's not look like that. We are going to now denormalize entities, right? We are going to now what? Denormalize entities. That's what we do. Now, what do you mean by normalization? It means that, for example, let's take looking for the one that we can take. Let's take okay. Let's take we don't have that example though. Like if we have something like a product category, products, and products of category, but we don't have that example. But looking at what we have on the screen here, instead of having procurement manager and the product table differently, we can, when we say denormalize means that we are bringing two or more tables together to form one table. So we can have product manager and the products the products that they sell or that they belong to or whatever it is. We can have them together inside one table. Now we have denormalized it, right? We have denormalized it. But a very good example also is the one I said earlier, is when we have something like a product category, product table, we now have product subcategory, which is like a higher level to product, and we now have product category. So that kind of hierarchy. Now, instead of us now having that as three different tables, product, subcategory, category, and product, we now have it as one table. That means that on one single table, you will see the list of all the products, the subcategory each product belong to, and the category each subcategory belong to. Do you understand what I mean now? So that is the normalization. That is the normalization. So when you see an architecture like that, that you see information about the entity on one single table, and you now see one big central fact table, like the sales table, that has that each of the entity, the dimensions, they are represented inside of that sales table. That's a star schema. That's a star schema, right? That's a star schema. So let's do something here, just some examples here practically that we can use to okay, before I even go ahead, Madam, do you have
Sir?
anything to contribute to the OLTP, like the meaning, the structure, the architecture?
I think I think your explanation covered everything. Except you want
Okay,
me to, yeah, it's covered everything, so there's not much to actually add.
okay, okay. We have Adebayo. Please, can you introduce yourself? I don't know who this is. Oh, sorry.
Yeah, it's the same Adebayo that Adebayo Abdurrahim.
I got.
Yeah, I'm just watching you guys. I don't be
What are you
young.
doing in this kind of class? This small class?
No, alright.
Yay!
Yes, sir.
I'll call you after the class. Sir.
No other bros.
Thank you.
Okay. Welcome.
Do you have anything to contribute to this OLTP and OLAP?
No, I'm just letting you know.
Don't mind him, Madam.
I'm just letting you know.
He's my guy at the top. Oh. He's just doing low key.
I'm just letting you know.
Please let us
Okay.
learn from you.
Abio.
Nike. I'm just letting you know. Thank you.
Okay, no worries. Thank you. Okay, so let's denormalize some tables here. I'm looking at the one that we can pick from. Okay, so Mamola, let's try that product and procurement manager. Let's try that one. So let all the information be in one table. Yes. Let's match them together. So yeah. No, don't put it there. Put it down.
Down.
So it's different from the OTP one.
I didn't copy it. Sorry. Come on. And then the procurement manager, yeah?
The procurement manager, yes. Like you bring the information also. Bring their information. You don't need to copy the name of the table again.
Okay.
Just the columns. So in a typical structure, it will not even look like the way you are pasting it. The
Yeah.
manager. So you know what? Instead of copying and pasting, let's rearrange it.
Okay.
So let's first have the procurement, the manager ID. The
Okay.
manager ID should come first.
Sorry, my
You
mouse.
can probably like drag it or something, or
Yeah. I'm coming. Let me close all this notes.
manager ID. Okay. Then we can now have the manager name. Yes. The product ID now follows. Then you can now cut and paste every other thing that is in products.
Okay.
Product name, yeah. So so if you can see now, because this might be new to Paul, you will see that now we have the normalized. So the manager, instead of separating the manager table and the product table from each other, we now have it inside one table. So each manager now you will see all the product that they are dealing with. Each procurement manager, all the product that you are dealing with, and those products too, you'll now be able to see even metadata information about them, like their name, also the bureau manufacturer, like every other attribute about the product, you will see it inside of this denormalized table. Is it clear to you before we go ahead?
Yes, sir.
Clear to me.
Sorry, Paul, is it clear to you?
It's clear.
Okay, thank you. So that's just laying the foundation to now. So as a Power BI person, or as a data analyst that's going to be using Power BI, in a typical environment, in a proper standard environment, you are not supposed to be using this OLTP. You are not meant to be connecting to an OLTP tables rather, because it doesn't make sense. It's not optimized for analysis, right? You're supposed to be connected to an OLAP that is optimized for analysis. That the tables there, they've been now, let's even, for this to even make very good sense, like for this to make sense, let's do like an AR diagram. Let's do like an AR diagram. You can see use did you know how to use Escali draw?
No, I use what's the name?
Which one do you use?
Sorry, is it EI? What's the name? I'm sorry. Let's see.
Okay.
Drawy.io.
Draw IO, Abby.
Yeah.
Okay, can we go there now?
Okay, sure. I put it on this.
Can we do like draw out that structure?
Can you see it?
Yes. So let's start. Try for free or what's okay.
Usually, wait, I don't know why that's asking me to sign in. It's supposed to be just free.
Oh, okay.
This one.
Hmm.
It looks like they changed their stuff. Before I didn't used to sign in, I just do it. So let me try
Just use
what's the
data,
name
Abby.
you
Let's
yeah.
try that Escali draw.
Yes.
That one too is like very easy to use. So probably let me see if I can quickly share my screen.
Okay.
Come in, sorry. I'm coming now. I'll share my screen now. Oh, you're already sharing your screen, so you're already showing it. Oh yeah, let's go.
Okay, I can start
Um,
sharing so you can share your own.
no, wala, no wala.
Okay.
So you can click on that square this thing, that square button, I mean, that square shape, and then you will drag it, you will draw it on the whiteboard. Exactly. So can you draw it, make it come down a little? No, it's too wide. So like
Oh,
it should
okay.
come down by like vertically, not horizontal.
Oh, okay. Uh,
It should be
well,
longer,
okay, longer.
not wider. Yeah. Uh, you cannot make it wider a little. You can make it wider a little to your right. It's okay. It's okay. So
Okay.
in this now, you want to type in something, you can double click on the middle. Yes, you can now type, for example, product. You can type product. That's the name of the table. Then come shift like enter or something to come down. Then put a space. Then product ID. Product ID. So let the table name and the column name be. Let it have space.
Okay.
After the pro, let there be like one space in
Oh,
between.
okay. Okay. Hold on.
Yes. Product ID, product name. So let's do like a small OLTP structure. Then we'll now do another small OLAP structure. Product name. You can now do product subcategory ID. Also product sub B ID. Sub B ID. No, sub. Sorry, I confused this. Remove the P.
Okay.
Yes. Okay. Good. So now copy and paste this same diagram, like this shape and everything. Copy and paste it. Control A everything, or select all or something. You copy and paste it. The second table will now be product subcategory table. This one will now be product subcategory. So this the first column here will now be product subcategory, product sub ID, product sub ID, product sub ID, product sub name, like subcategory name. Then we now have product category ID. Product sub, just go say sub name, that's subcategory name. And now we now have products.
What's the last one?
Products category ID. Category ID. Sometimes on something like you visualize it that people will understand it. And I'm doing this for the sake of those that will still watch it on YouTube later or something. Right. So the third table now, copy and paste again. The third table will now be the product category table. Oh, you're copying everything. uh-huh. Okay. So this one will now be product category now. Product category table. Yeah, category ID and then category name. Exactly. So let's now link it all together now. So the product table, move it a little to the left. Let the subcategory come after. Then the category now comes after that one.
to lock it. Yeah. Oh, sorry.
No, lock means you've locked it. It's not moving.
Yeah, I wanted to lock this.
Oh, okay. I forgot how to
icons.
do that too. So that I move the two together, Abby.
Yeah.
No, you highlight
grouped.
it together. Like
I've grouped it, yeah.
no, I mean you can highlight the two together.
Like the table and the stuff inside, yeah.
Yes, you will
Yeah.
do like you want to select that particular area. But don't worry. Just leave it.
Okay, so
put
this
product
one.
subcategory beside it. Move category away. You see that thing that you just did now, the way you highlighted that one. That's the same way you highlight everything together.
Yeah, I'll group it. Yeah.
Exactly. Okay. Then you now move it.
Oh. Oh, okay. Thanks.
Good. Now do for that one too. Then move it. Okay. Now you see that what's it called? You know what you do for me now to make this thing make sense. The product table, move it downwards a little, move it down a little.
Okay.
Move it down a little. Let it come down. Let it come down. Group it. Let it come down. Thank you. Thank you. Thank you. The subcategory now is okay the way it is, but move it down a little. It's okay. It's okay. No, don't let it go to that one too much. No, let it come down a little more. Come down a little more. It's okay. Then product category now should go up a little. Can go up a little. So let's now do the last one before we do the linkage. Let's now do the last table now. That one is now what's it called? The sales table now. The sales table. We will now have the sales table. So inside here we can have something like the order ID. We can have the product ID. We can now have product ID, quantity, sales, all of those things. Quantity, sales. And don't worry, it's okay. We don't need much. Just to explain this thing. So you can bring down that sales table, like drag it down. No, it's already grouped.
Yeah, I'll group it again.
Okay, you can drag now. Good. No, drag it down. It's okay. So now you will now link. You see that where you pick that shape. You see that arrow, that thing that's showing arrows to the right. No, the one showing the logo showing arrow to the right. Beside the shape you picked. That same place you went to.
Yeah, this one.
Just that line, you will see the arrow.
Oh,
you're right. There's the arrow there. So link the product table now to the sales table. Exactly. Thank you. Now you will now link. You go back to that arrow again, or maybe go back to the arrow again. You will link the product table to the subcategory table. Then you will link the subcategory to the category. Now, thank you. This is where we are going to. Now, can Paul see this now? So if you look at this little small architecture that you see here now, this is an OLTP architecture. If you bring this, if you connect to this kind of structure inside of your Power BI, it's going to give you a lot of problem and complication. Do you understand what I'm saying? Because of the the structure, the architecture, the ways tables link to each other. Because this one now is in terms of hierarchy. If you see product linking to subcategory links to category, all this makes that calculation very complex with this kind of structure. So let's now do an example of an OLAP structure. So you can scroll down, you can copy any of the table that we already have there. So copy the products table. Okay. Let's now do a typical OLAP structure. Yes. So so you have just one table called product, just one table called products. And in that table, you have product ID, product name, product sub ID, product sub, what's this subcategory name, product subcategory name, product subcategory name, or just sub something, sub name, category name. We now have products category ID. You see that all the information that we have in the three tables, they are now in one table. Is it clear to you now?
Yeah.
They are not in one table. So the bringing together of all the
So sorry. So would this also be like denormalization, like you were talking about earlier?
Yes, this is the normalization.
Yeah.
So you have brought in all the information from all the three tables inside one table now. It's now one single table, right?
Okay.
So this is an OLAP structure. This is the way OLAP looks like. And this is the one that analysts and Power BI developers work with or connect to. So you can now bring in back that sales table to copy the sales table to bring it, and only this one single product table will now connect to the sales table. So this looks very simple, easier. When you're analyzing in Power BI now, you can see sales by product, sales by product category, sales by product subcategory. Is it clear, everyone? Okay. Now, the concept of normalization and denormalization, is it clear to you?
Yeah.
Okay, what I will give you as assignments for you to do, for everyone that has not heard of the concept before, not for everybody, is for you to go and read about different normal forms. We have first normal form, second normal form, and third normal form. But the one that they usually used mostly in an OLTP architecture is third normal form. And all those first normal form, second and third normal form, they have their own, they have like their own, what's it called? Like that features, attribute stats that relates to them. First normal form has a condition that you must meet. Before you meet when you call something second normal form, it has to first meet first normal form, right? It has to meet first normal form requirements before you can become before you can go to second normal form. So read about that on your own, Sha. It's not like really, you don't really need it for Power BI scope, but it's just like a foundation that everybody must have. Okay, let's quickly move to the next thing. Okay, dimension. Okay, so I think everybody understand fact and dimension, right? We talked about that a lot last week. Fact table, dimension table. So what's dimension table, Paul?
Dimension tables contain non-repeatable or non-transactional data, right? So
Non-transactional data. Okay, but what do they really contain in terms of business context? What do they really contain? Or what do they represent?
The way I'll put it is like descriptive information, right? So for example,
okay,
in a DIM table, right, you have like product type. They have unique IDs or primary keys.
Take it one at a time, Paul. You are saying many things together at the same time. Make it simple. Explain to a 5-year-old.
Okay, dim tables, they have descriptive data, right? So they're
Okay.
is a table that basically contains what is being described. So for example, if you have, say you work at a sales company, right? You're selling products. Product dim table would have a list of all the products you are selling. So for example, say you're selling ice cream, right? We'll have all the flavors of ice cream listed on that table.
Mm-hmm.
Yeah, that's the way I would describe like a dim table.
So the better way you have said it was that it represent different business entity and their descriptive attributes.
Yeah.
Because when it has a list of ice cream, it's not just listing different ice cream. To tell you the ice cream colors, the flavor, just like you said. Uh, Probably any other thing. I don't know. I'm not an ice cream person. Probably any other information that relates to that particular product. Maybe the packaging information. I don't know. It can be anything. It can be anything.
No
So
worries.
yeah, that's just it. Okay. What about fact table?
That's why you have like transactional data, right? So it's going to contain basically repeatable information. So for example, like a fact table is going to contain the number of sales of a particular product. So if, for example, you have a dim table that lists all the products of ice cream, right? The fact table is going to contain like how many, for example, chocolate flavor ice creams was sold on a particular day, right? So it's going to have
Mm-hmm.
like repeatable like instances.
Okay. So
Yep, that's the best way I would
I,
explain it.
well, I would not really like you using the word repeatable instances. The word transactional would be enough. And then probably what you will have said was that every of the dimensions, uh, it is in fact that we'll see their operation, like we'll see their transaction. So what I mean by that is that for fact table now brings everybody together, right? So you will know the product that was sold, at what quantity, at what unit price, probably at what unit price, in what location, what customer bought the product. Like every information about the different entity will now come together inside one central table, now called the fact table, right? So I think the reason why you said repeating information is that probably what you mean by that is that probably a customer will buy several times. So probably their customer ID will show several times. Uh,
Yes.
but the that word repeatable information might not really that word might not really, I don't know how
Like
to
do
put it.
I
Yeah,
not do justice
because
for
when you
like
say repeatable information, it means like it's a table that contains repeated information.
yeah.
So it might sound confusing for somebody that is hearing it for the first time.
Okay.
So what we can say is that a particular customer can appear several times because they bought several times. A particular product was bought several times, so it will appear several times on that table. In a particular location, we had transactions happening in that place at several times and interval. So the location ID will repeat itself in that table. Maybe you'll have said it like that.
Okay. Fair enough. Thank
Okay,
you.
so one important thing we talked about, primary key, foreign key. If you guys remember, primary key is a unique identifier. For example, in a product table, we have product ID. You don't have two product ID sharing the same. I mean, one particular product sharing the same ID. It doesn't work like that because every product is unique, and uh, one row is for each different product. That one is clear. Same thing goes to other entities like customer and the rest. I'm trying to move very fast. Now, it's a concept that I didn't probably explain, but I know that Adebayo and Anandola will understand that is the concept of what we call slow changing dimensions. So let me quickly
Mhm.
explain that to you. So go back to the Excel. Go back to the Excel. Now open a new page, like a new sheet rather. Let's try for products. is that example that this time around now you have it horizontal now. So you are not listing stuff now. You are like doing an actual table. So do
Okay.
product ID as the first column. Product ID. Then just do product name. We don't have much time, so we're doing many things. Product name, right? And do unit price. Unit price. You wrote unit price. Are you from the UK?
In it.
Unit price. And let's have another column called valid from.
From?
Valid from and valid to or something. I can't remember. Maybe Sadibayo can help me. Is it valid from and valid to? Abi?
Yeah, you can use that. I can use effective start
You
date
can use valid from and valid to. Abi? Okay.
and effective start date, effective finish date, something like
I
that.
can't hear you.
Effective start date.
Thank you. Effective start date. Yes, this is that one. Effective start date and effective end date. Yes, thank you.
So,
Effective end dates. Yes. Okay, thank you. So, which product ID 101? Product name, just put like what product can we just put self? I don't know. You can say pillow or something like that. No, do product ID 101, 101 again, repeated.
Okay,
The same
repeat that.
101 again, repeats. Yes. So give it the same name, pillow. Pillow, the same name. No, just copy and paste the first one now.
I wanted to
So
do the plus
we
table. I
don't
don't want
we don't
to
need the third one. Remove
go
the third
down.
one.
Okay.
You can give that one 102 or give it another product name entirely. So unit price, make it 10 here, and the second one make it 20. The price has increased. Effective start date. Let this one start from any date of your choice. Put any date of your choice there. Thank you. So this price ended what date? Put any date of your choice too there.
Boxing Day 2025.
1 day now. It's too
Christmas
it's
sales
too
has
close now.
finished. Okay, let me put this one to be like
Look for
10th of
something.
December.
You can even change the month to like September or something. 09.
Let's put this on to 26th of maybe July 2026.
We never even reach July this year.
They are
Okay,
accelerating.
no wahala. So the next date will start from 27 now. The next date after the last effective end date.
Mm.
That's 27/07 2026. Now, the effective end date of the new price. So it depends on the company and the way they are doing the architecture. So they might have it like it might be empty. No, it's empty. It's still the active one. It's empty. Or you might see something like a maximum date, like 9/99/12/31. You get what I'm saying? So let me
Yeah,
explain to
yeah.
Paul. Paul, sorry, I'm calling your name all the time. Sorry. It's because the
Or
2 people here, they are already your guys. They understand it.
I'm not
So,
a girl.
so
I'm not gas well. I beg, I dey learn.
don't mind
I'm
Mr.
still
Adebayo
learning,
Abego.
Maybe Mr. Adebayo, but me,
So,
I'm still learning.
so this is it. Let me explain. So we call it slow changing dimension. Now, Paul, you already understand dimension table. You understand what it means already. You have that foundation. There are situations whereby, as a Power BI developer, we are going to be working with this kind of tables. It's still a dimension table, but it's called slow changing dimension. Now, look at a typical example of what we just did now. The product ID, this particular product, this product ID 101, this pillow, The price was $10 before. Later, the price changed. We want to capture. Now, this one is called STD type 2. It's type 2. So this is the assignment now, Paul. Go and read about STD type 1, type 0, and type 1. Forget about type 3 for now. You might not even need it. Type 0 and type 1. So let me just quickly say it. For type 0, nothing changes. Abi? Am I correct?
Yes, nothing changes.
Okay, for type 0, even if the price change, there's no record about it.
Yes.
Nothing changes. For type 1, we also replace the new price with the old one.
Yeah.
Is my English correct?
Yeah, I think it's correct. It truncates the
So
records and replaces it.
yes, it truncates and replaces it with the new record. So instead of seeing 10, we just start seeing 20. But the problem with that is that we will not be able to track historical record of transaction of that product. That when we were selling it at 10 naira, what was our sales like? When the price increased to 15 naira, what was our sales like? There will not be that historical analysis, right? Because if we are replacing with the new price. But for STD type 2, is what the example you are seeing here. You know that dimension, they don't usually change as fast like the way fact table gets updated from time to time. So this track history of price of products. This same thing can be applicable to probably in a company that you have staff. People change location, they can be transferred to another city. People marital status change. From single, they get married, right? What again can make people information change? People can say they are changing their address, their email address with the HR, and say, if you want to send me any correspondence, right, this is my new email. So things change, like people change location, address, people change marital status, people are being transferred to a new place, people change position, yes, people get salary increments. So is that table that will be tracking all those changes? If you look at this example now, very nice example, there was an effective start date of the previous price, and there's now an effective end date. That means that is the date the $10 price ended. Is that clear to you, Paul? And a new price started on another date. The reason why you're not seeing that the effective end date of that latest price is empty is because it's still the active date price at the moment, and it does not ended yet. If it's end today now, you will see effective end dates there. A new effective start date will start for a new price. Does it make sense to you, Paul? Is Paul still here with us?
Yes. Can you hear me?
If it's not clear to you, let me know.
Okay, so for what I know, right?
Yeah.
We're talking about like the different types of like dimension tables, right? So slow changing dimension, like for example, times 0, it doesn't change.
Nothing never changes.
Okay. And for SCD1, like
we
it
overwrite.
changes, but yeah, you lose the historical data, right? So it just replaces with the current whatever new
No, we
information is there.
overwrite whatever the new record is with. New record is, we overwrite it. It means that in that dimension table, you just start saying 20 in the unit price instead of 10.
Okay.
That's for STD type 1.
Okay. All right, no worries.
We are overwriting it. We are just changing it. You're not keeping any record of what was the past price.
Okay.
Do you understand now?
Yeah, that makes sense. Yeah.
But in STD type 2, is now this one that you're seeing on the screen. That one keep a record of history of the prices. When we implemented the first price, You saw the start date of that first price. You saw the end date of that first price. Later, we increase the price of this pillow to $20. You now see an effective start date. That's the date we implemented the new price. And the reason why the effective end date is still empty is because that price is still the active price that we have, the latest price that we have.
Okay.
Makes sense now,
Yep.
right?
That makes
Uh-huh.
sense.
So this one is now keeping record. With this one now, if you connect this side of table now, if you connect it to what's it called? If you connect it to Power BI now, like sorry, your sales report, sorry, the sales data, you'll be able to see what the sales was like when the price was $10 and what the sales was like now when the price is $20. You understand what I'm saying?
Yeah.
Because there's that historical record of the changes that is happening to that particular dimension, which is the products. Is it clear? Okay, we
It's
have
clear.
like 5 minutes to go.
Okay.
Let me quickly explain something to us. So now, let me ask a question, and I'll be asking Madam Dola and Paul. So don't forget that we said dimension table. The primary key is usually unique, right?
Mhm.
Like product ID, for example. But in this case now, it's not unique anymore. So how do we still ascertain uniqueness? I'm extending this to Adebayo too. How do we see ascertain uniqueness here?
So when you say ascertain uniqueness, like if we are referencing, let's say, the product table from another
Uh-huh.
table, yeah.
If I mean, like, if we want to connect this table now to a sales table,
To a sales
and don't
table.
forget that product ID is no more unique
Mhm.
because of the slow changing dimension. So how do we still ascertain that each row is unique rather? How can we still implement that uniqueness? I don't have to put my words. I think,
Yeah,
but
it's
okay,
understood.
go ahead, sir.
Now, I just want to like my opinion. I'm not saying what I'm saying is right, so anyone can
Okay,
correct me.
okay.
My understanding is that when you have a dimension, just like you said, a slowly changing dimension is a kind of dimension that hardly changes. So usually when you have a dimension, there are certain columns that has to be there. Number one is going to be kind of a surrogate key. When I say
Surrogate
surrogate
key,
key, I
yes.
mean it's going to be something like when you create an SQL now, it's going to be like kind of going to use a function called identity, which means it's going to be like onto increments by one or whatever you want it. That's number one. Number
Yes.
two, so another column that has to be on SCD is effective start date, just like you said, the effective finish date. And there's one other column which is mostly required, I would say recommended, but some people don't use it. We call it like is active, which
It's
is going to
active, yes.
contain like two information, like we call it a Boolean information, either yes or no, or one
Oh,
or
yes.
two.
Or 0 or 1. Okay.
Yeah. So for the surrogate key, which is going, so this product key is not going to be the primary key anyway. It's going to be like a kind of business key.
Thank
So
you. Thank you
okay.
very much. So what he's saying is that product ID, thank you very much. Very nice contribution. What he's saying is that product ID that you're seeing there will no more be the primary key now for this table again. We'll now have one additional column, right? That additional column will now be called what is called a surrogate key. So that one can now be auto increment, just like the way he said it, auto increments. It means that key doesn't have any business meaning. It's just giving uniqueness to each row. It's just saying, oh, yeah, start from 1 and auto increment by 1. That means from 1, 2, 3, 4. It doesn't care whether the changes in price or not. No business meaning or anything, just auto incrementing numbers. Does it make sense? So in the scenario like that, what we now have in our stakes table now, the fact table will now be that particular ID. So what you do now for Madam, what you do for me now is that you will right click on column A, and you will do insert. No. The O column, it won't work like that. You now call it surrogate key. You call it surrogate key now. Yes, so you now have 1, 2, it will now be auto increments. So this one will now make each row now to be unique. And this one will now serve as our primary key now for this SCD type 2 table. Because that product ID cannot be the primary key again because it's not unique because of the changes in the prices of products.
It's kind of like a temporary unique key, like a surrogate key. So I said it's kind of like a temporary, like unique key, right? In a sense.
Well, I don't know whether the word temporary is right, but it's now the primary key now because it's now making every row to be unique.
So if we go to the sales table now, I want to like maybe join them or something. So we are going to refer to the surrogate key now.
The surrogate key is now what we have on the sales table.
On the sales
as the primary key for product table now.
For product table, okay.
No more, not product ID again.
Okay.
Yes. So that's what we now allow you to be able to now track history based on the changes. Is it clear?
Yes.
Another column that everybody talked about is you can add it to as column G, is active. So when it is not active, it is no more active, the row will be 0. When it is active, the row will be 1. So you can add it as column G, yes.
What's it? Active?
Is active, is underscore active. Is active. So the one that is not active again is 0. The row 1 is no more active because that price is not active. It's not the latest price. That one is still active, so it's 1. So that's the way it usually looks like. Is it clear to everybody? Any contribution, any addition? So when we come back on Thursday, we are going to talk about other things. Let me see the list. We'll talk about surrogate key today. We'll talk about composite key and natural key. Composite key and natural key. We'll talk about this one already. Star, snowflake. I think we even touched that. Okay, we've not touched snowflake schema. We've only touched star schema. Okay. We'll touch based on snowflake. What again? Then we'll talk about joins. Talk about joins. Left, inner, outer, right. And we'll now do like how it works in the Power Query side of things, which is like when you do merge queries. So we'll now go to storage mode. We'll talk about import mode, direct query mode, dual mode. We not even have live connection. There's even direct link mode. So guys, thank you for joining. Thank you for everybody for contributing and for being active. We are going to be meeting again on Thursday, same time. Sorry.
Yeah. Thank you, everyone. Bye.
Thank you. We'll see you guys again on Thursday.
Yeah, thank you. Bye.
Bye.